In this video, we're going to discuss about arithmetic sequence. This topic is so simple and yet so important because you can find this in all major examinations of the land. You can find this in civil service examination, board examinations, college entrance examination, and even in employment examination. Join me as I discuss how to deal with arithmetic sequence using formulas and using calculator techniques. An arithmetic progression or arithmetic sequence, AP in short, is a sequence of numbers such that the difference between the consecutive terms is constant. For example, 1, 2, 3, 4, 5, and 6. The difference between two consecutive terms is always 1, and it is not changing. 2 minus 1 is 1, 3 minus 2 is 1, and 4 minus 3 is 1, and so forth and so on. Example number 2. We have 2, 4, 6, 8, 10, 12. If you will notice, the difference between two consecutive terms is always 2. 4 minus 2 is 2, 6 minus 4 is 2, and so forth and so on. The difference is not changing or constant all throughout the series. Example number 3. 3, 5, 7, 9, and 11. The difference between two consecutive terms is always 2, and it's not changing all throughout. 5 minus 3 is 2, 7 minus 5 is 2, and so forth and so on. And last, we have 4, 8, 12, 16, and 20, and then ellipses. The difference between two consecutive terms is always 4. 8 minus 4 is 4, 12 minus 8 is 4, and so forth and so on. And it's not changing or constant all throughout. So therefore, whenever you see a sequence and the difference between the consecutive terms is constant, then it is an arithmetic sequence. The common difference is represented by small letter d, or d is equal to the common difference. To get the nth term of any arithmetic sequence, we use the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times d, wherein a sub n is equal to the nth term, a sub 1 is equal to the first term, n is equal to the number of terms, and d is the common difference. Let us now proceed with an example. Find the 20th term of the arithmetic sequence 1, 2, 3, 4, 5. We are given the common difference of 1 because 2 minus 1 is 1 and 3 minus 2 is 1 and so forth and so on. The first term is equal to 1 and the number of terms is obviously 20 in this case because we only have a common difference of 1. We are asked to find for the 20th term or a sub 20. Therefore, we have the solution. A sub 20 is equal to 1, which is the first term, plus, what is n? N is 20 minus 1 times d. D is 1, therefore, the answer is 20. We have another example. Find the 8th term of the sequence for 8, 12, 16, and ellipses. We are given the common difference of 4, obviously because 8 minus 4 is 4 and 12 minus 8 is 4, and it is not changing all throughout the series. So D, or the common difference, is 4. The first term is equal to 4. And n, or the number of terms, is 8. because we are asked to find for the 8th term. So therefore, a sub 8 is equal to the first term, which is 4, plus n minus 1, which is 8 minus 1. That becomes 7 times 4, and that becomes 28 plus 4. The answer is 32. Alright, let us now try to solve this problem using calculator techniques. Find the 20th term for the arithmetic sequence 1, 2, 3, 4, 5. Before, we solve this problem using the formula as shown in this slide. Right now, we are going to solve it using Casio calculator technique. As you can see, my emulator here is at normal mode. So what we will do is to press mode and then press 3 for start. Now, if you are in arithmetic sequence, or if you want to solve arithmetic sequence, you have to press 2, a plus bx, because arithmetic sequence is addition. So press 2, and then the x column here represent the position of the terms. For example, here, 1, 2, 3, 4, 5, that's the value of the terms, that's y. And the position is, this is first position, second position, third position, that's x. So therefore, we will place here 1 equals, and then 2 equals, and then 3 equals. You can only input 2 if you want, and it will still work. 1 and 2 position will do it. But in this case, I included 3. Now, y here corresponds to the value of the term. The value of the term in that position. For example, in the first position, we have a1, which is equal to 1. And then a2 is equal to 2, and a3 is equal to 3. Do not confuse yourself. They are not the same. This pertains to the position, and this pertains to the value of your term. After inputting the data, you can now press AC. Do not worry, it will not be lost. And then after pressing AC, you have to press Shift 1. And then we have to press 5. Now we are going to find the nth term. If we're trying to find the nth term, we will be finding for the y hat. So we will press 5. After pressing 5, we will have to press 20. Okay, so that's the 20th term. And all you have to do is to press equals, and there you have it. We have the same answer using the calculator and using the formula. Here's another one. Find the 8th term of the sequence 4, 8, 12, 16. Again, we have to press mode and then 3, and then pag if we are in arithmetic sequence, we have to press 2. Now, x pertains to the position. Again, this is the first term, or position number 1, and position number 2. Now, y pertains to the value of the terms in that position. So at position number 1, we have 4. The value of a1 is 4, and the value of a2 is 8. This time, I'm showing you that even though we only inputted 2 values for x and y, this will still work out. Now we have inputted all our data, we can now press AC. And then Shift 1 for stat. And then again, we are only asked to find for the nth term. So we have to press 5 and y hat. And we are asked to find for the 8th term. Press 8 and then press equals. You already have your answer, 32. The same answer that we are getting using the formula. So that is how you use the calculator in solving for the nth term. Alright, let us have another example. Find the 22nd term in the arithmetic progression if the fourth term is 8 and the 10th term is 29. In this example, you will now clearly visualize how to properly input the values in your calculator. Again, if you can see the emulator, you can see that it is in normal mode. What we're going to do is to press mode and then stat 3, and then if we are in arithmetic progression, we press 2 for AP. X will be the position of the terms and Y will be the corresponding value of that position. So let us try to input X. We have fourth term, so equals, and then we have another term which is the 10th term. So what will now be the value of the fourth term? It will be 8. And then what's the value of the 10th term? 29. Okay, so after inputting the value or the values, we have to press AC. Now, Shift and then Stat. Let us try to, we are asked to find for the 22nd term. It is just Y hat. 5 and then Y hat. Insert the 22nd term, and there you have it. The answer is 71. So try to solve this yourself using the long method and find out if you are getting the same answer. To get the sum of terms, we will use the formula n is equal to a sub n minus a sub 1 all over d plus 1. A finite portion of an arithmetic progression is called a finite arithmetic progression and sometimes called arithmetic progression. The sum of a finite arithmetic progression is called an arithmetic series. Example of an arithmetic series is 2 plus 5 plus 8 plus 11 plus 14. If you can notice, they have a common difference of 3. So what's the difference between an arithmetic sequence and an arithmetic series? Yes, you are correct. An arithmetic sequence or progression is just the sequence of numbers having common difference, while an arithmetic series is the sum of a finite portion of an arithmetic progression. In short, whenever you are getting the sum of an arithmetic sequence, then that is an arithmetic series. To get the sum of an arithmetic series, we use the formula S sub n is equal to n times the quantity a sub 1 plus a sub n all over 2, wherein S sub n is the sum of terms, n is the number of terms, a sub 1 is the first term, and a sub n is the nth term. Example number 1. Find the sum of the first 6 terms in the series 1, 2, 3, 4, and then ellipsis. we are given the common difference of 1, obviously because the difference between 2 and 1 is 1 and 3 and 2 is 1. The first term a sub 1 is 1 and the nth term, obviously because we only have a common difference of 1, is 6 and the number of terms is given to be 6. We have solution s sub 6, or the sum of the first 6 terms, is equal to 6, which is the number of terms, times the quantity a sub 1, which is 1, plus 6 all over 2, and that will be 21. Number 2. Find the sum of the first 8 terms in the series 3, 7, 11, and 15. Given, the common difference is 4. 7 minus 3 is 4, 11 minus 7 is 4, and it is constant all throughout. The first term is 3, and the nth term, or the number of terms, is 8. We do not know what is the nth term. All we know is we have 8 terms. So, to get the nth term, or a sub n, is equal to a sub 1 plus n minus 1 times d. So therefore, a sub 8 is equal to the first term, which is 3, times the quantity n, 8, minus 1, times the common difference, 4. If you will notice, 7 times 4, we will be having 28 plus 3 is equal to 31. So the 8th term, or the nth term, is 31. Therefore, the sum of the first 8 term is equal to s sub n, or s sub 8, is equal to 8, which is the number of terms, plus the first term, which is 3, and the last term, which is 31, all over 2 is 136. Again, let us try to use the calculator in solving for the following examples, and try to compare if we are going to have the same answer. We press mode, and then we go to stat, and then we are in arithmetic progression. We have to press 2, and then we have to press the position 1, 2, and then the third position. Now let us try to press y, or the values of the terms. The first position has 1, the second position is 2, and the third position is 3. So this time we are asked to find for the sum of the first 6 terms. So therefore we will press AC, and then we have to press the sum. Therefore the summation of x, alpha x, and then y hat. We need the y hat, therefore reg, and then y hat, and then comma. So it will be from 1 to 6. From term number 1, comma, to 6. There you have it. And then press equals, that will be 21. So this 21 here is equal to 21. So we are having the same, be it calculator technique or be it the long method. And let's try to solve this second problem using calculator. Mode, stat again, and then 2. And then the sum of the first 8 terms in the series. Okay, so we have 1, and then let's try 2, and then let's try 2 numbers only. And let's see if it will work. The first position will be 3, and the second position has a value of 7. That's y. Okay, and then do not be afraid to press AC, it will be there. And then shift summation of x and then xy hat xy hat. Therefore, comma, comma, and then the first 8 terms. So 1, comma, 8. And there you have it, 136. Easily without any computation, you already get the answer 136, and it is equal to 136 using the long method. So that is how easy it is to solve problems involving arithmetic series or sequence using calculator techniques. We have our last example. Find the sum of odd numbers from 1 to 61. Logically, we have a common difference here of 2 because it will be odd numbers. So let us try to use the calculator. Mode, and then stat, and then we are in arithmetic progression because we have a common difference of 2. Therefore, press 2. Okay, now, so we have to press here the first position, the second position, and the third position. The first position will be, of course, 1 because that's from 1. And the second position will have a value of 3 because that's odd numbers. And the third position will be 5. Okay, we are finished inputting our values. We can now press AC. Now, what we are going to do? This 61 pertains to the value of the nth term. We do not know what position is this 61. In short, we do not know what is the how many number of terms before we have the value of 61. So therefore, what we're going to do is to press shift and then 1. This time, we are going to press 4. Okay, so 4 will give us the x hat. Okay, now if we will input here the 61st and then x hat, what will be the value of the 61st x hat? It will be 31. So it will be the 31st term. So from 1 to 61, if we are going to write down the series of odd numbers, we will be having 31 terms. Okay, so it is now clear to us. And then what we're going to do is to press AC, shift, summation of x, summation of x, alpha x, therefore. And then we will have y hat, number 5, summation of xy hat, comma, from 1 to how many number of terms? From 1 to 31. There you have it. So let us just press equals, and then you will have 961 as your answer. Let us try if that is correct. It will be, let us try to use the long method. Let us go to computation. So it will be n times a1 plus a to the n. a1 plus a to the n is 1 plus 61 times n. The n that we got is 31 times 31. And wait, that's times 31. So 1 plus 61, then times 31 all over 2. That will be 961. So we are getting the same, both using formula and calculator techniques. I guess I have shown sufficient example to illustrate how to use your calculator in solving for arithmetic sequence. Thank you, and may God bless us all.